Hello everyone, we are back with another Leetcode problem. This is also one of the problems inside the blind 75 list. Okay, so this is marked as a hard problem, but yes, it has some conceptual things which makes it hard, but the thing is it's not that much challenging. Once we discuss everything, things would be much more clear to you, and the concepts that will be clear through this problem will also help you solving other problems. Okay, so let's start to see what is the problem description. So let's talk about the problem description. The title of the problem is the binary tree maximum path sum. So you can probably make some assumptions about the problem. Okay. So first of all, we need to know what is a path in a binary tree. So the definition is at the beginning here. So a path in a binary tree is a sequence of nodes where each pair of adjacent nodes in the sequence has an edge connecting them. A node can only appear in the sequence at most once. Okay, and note that the path does not need to pass through the root. So that is the important thing. Okay, so it's a sequence of nodes where the nodes are actually connected through edges. So suppose if this is a tree, let's say I draw a tree for you. Okay, so in this tree, let's say some of the paths. So it's a sequence of nodes where the nodes are adjacent. So say starting here, this is one path. So it starts here, ends here. Okay, so this is a path. And then let's have other paths. This is a path, okay, with just one edge, sorry. Just put the edge back. Maybe I should put it back with the right color to make it less confusing. Okay, and then say other path. So the path doesn't need to be consisting of root, but suppose this is a path, say this, okay? So it starts here, ends here. So this is also a path. Okay. So let's add some more nodes into this tree. Okay. So another important thing is each of these nodes have values. So when you are calculating the length of the path, you have to consider these values. Suppose this path length is 9 minus 10 equals to -1. So this path length is -1. Okay. Or this path length, say this is 15 plus 20 plus -10. Okay, so it is 25. So this path length is 25, starting here, ending here. Okay, and okay, so we have to find the maximum path length. So let's think about this. These maximum. Oh, another thing is the values here. As you see, the values can be anything between -1000 to +1000. Okay, so that means it's important thing. It's an important constraint. So it can be negative. So it doesn't mean that adding many nodes or edges will make the path length bigger. There might be nodes which have negative value and they will actually decrease the path length. And so let's just start building our intuition. The first thing is probably, or you can just think yourself. You can pause the video, think yourself, and then come back again. Okay, so if you have already thought about it, probably you have thought like this, at any node, say this node. Suppose this node is part of the longest path. Okay, so can we say like this? There are multiple ways. So it can be, say, this. So this is suppose, or let's draw like this. Once I'm drawing, I'm also removing some of the nodes. Okay, so say starting here, this, and then this. Okay, so this. This is suppose the largest path in the whole tree. Did you get it? Okay. So that means whenever we actually, obviously we have to traverse the tree using a traversal algorithm. So whenever we are traversing the tree, after going to every node, we have to check like, so, okay, so this is one possibility. Or can it be like this? So can it be, say, can it be the longest path in these whole trees? Just this, right? So this, suppose this is big, this is big, this is also big. So just this is the longest path, right? Or can we say that just this part is the longest path, starting from here to here? Okay. Or can we just say that only this node itself, suppose this is so big, 100, this node alone is the longest path, because everything else that comes from here is minus something, let's say minus 10, minus 50. So including those doesn't help. This by itself is the longest. So at one node, at any node, we can say that this node itself might be contributing to the longest path, or it's getting the like the longest path from this portion plus this can be the longest path, right? So longest path, or we can say plus the longest path might extend even to the right subtree, right? So we can say the longest path might be either like this, right? Or just this, or this, right? Or it extends in both places. It can be like this, right? That means whenever we are actually checking the longest path in any node, we have to check between all of them. Am I alone the longest path, or me plus the longest path from the left subtree, or me plus longest path from the right subtree? Or me plus longest path from the left subtree plus longest path from the right subtree? Any of these can be a candidate for the longest path calculation, right? Whenever I'm visiting any node, that is fine. Now, another thing is, I have to provide this information to my parent as well, right? Because it might be the case that the longest path doesn't is not here. It's somewhere like is somewhere here, which involves this node, right? Okay. So what do I pass to my parent? You see, I cannot pass everything. So suppose if I pass, say, okay, just different colors. Let me check these colors. So say if I pass these thing to my parent, say, okay, get this. Actually, it's not going to help my parent, because you see, I cannot create a path using this, right? This is not a path. Can you see that? So this blue color, this is not a path. So what can I provide him? Either I provide him the longest path from the right, or I provide him the longest path from the left, right? Or I provide him nothing, just myself, right? So when I am actually passing back to my parent, I don't need to pass these kind of paths. I just have to pass one-sided paths, either the longest left, or longest right, or longest left plus myself plus longest right, or just myself. Okay. So here goes the concepts. Just think about it. What I have said, just think about it. Take your time, discuss, think about it. And this longest path can be anywhere in the tree. It can be here, or the longest path might be here. Okay, so everywhere I go, I have to check between these things. Okay, so let's go back to our code and try to see how we can code this. So obviously I'm coding in Java. Okay, so this is the function path sum. So what I do is initially, so when I go to every node, I have to check between these options, right? Every node, if that node alone can be a candidate for the longest path, or that node plus the longest path that it gets from its left subtree, or that node that and the longest path that it gets from its right subtree, or that node and the longest path it gets from both directions can actually form a path. And each of these are the candidates for the maximum path sum, because the maximum path length can be anywhere in the tree, right? Okay, so if I go back, you see I have a variable max path. I put it as a global variable, so I will initiate with the min value, integer dot min value, and whenever I have a longer path length, I will update this. Okay, so this is the function max path sum, and we are given a tree root. We start here, and then I define a helper function. So I'm calling the helper function, and inside the helper function, this max path is getting updated every time when it visits different nodes. And finally, I return the whatever is the largest one, right? Okay, so this is the important function, max path sum helper. Okay, so this is the function. You see, if at any point I reach a node where the node is null, I just return 0, because it doesn't have anything to contribute, so 0 length. And then I calculate the max left. That means, suppose I am here in this node. So suppose I am here in this node, right? So I ask here, ask my left subtree, hey left subtree, what is the longest path you can give me? What is the longest path you can give me? And then I also ask my right subtree, what is the longest path you can give me? Because I'm trying to see if I can use them and add myself and create a even longer path, right? Okay, so I call the max path sum helper with my left node as well as my right node. They will give me recursively, they will give me the max path length from their side. And remember one thing, my left subtree and the right subtree, they are not going to provide me a path like this. They are not going to provide me a path like this, right? Because that way I'm not going to create a path. So obviously what they're going to do is they're going to provide me either a path like this or something like this. Okay, so that I can create a path. And I already discussed this. Okay, so I'm in the current node, right? I got the max left, max path length from the right, and then I try to update max path, this one. The candidates are, you see, integer dot max. This one takes 2 parameters, so I have to call it multiple times. Let's go to the inside one. So this is the last one. I take the current max path length and then compare it against the node's value, because the node itself might be the longest path, right? It might be so big. Okay, I get the highest between these two and compare it with max left plus the node's value. Okay, and then I get another max out of these three, right? I compare it against the node value plus the path length that I got from my right. Okay, then I got from these four, I got one max. And finally, I try to add max left, max right, and my own value. So these are the 5 options, right? So these are the 5 options. So the node has these 4, and the 5th option is the current path sum. So out of these 5, I get whichever is the largest will be updated to the would be the new max path, right? New max path. And as I said, then it's time to return to my parent, right? So what do I return? So you see, to my parent, what I am going to return is I am either returning this or this, right? So or myself. So basically, as I said, like here, yes, erase this. So suppose this node is returning here, right? What is going to return? Either it returns the left plus this, right? Either it returns this to the parent, because only then the parent can make use of it, or it returns something like this, right? So this plus this path. Okay. So when I'm returning to the parent, I return max left plus my value, or max left plus max right plus my value, or myself. Okay, so these are the 3 options that I return to my parent, and my parent can use this to trying to create its another path which involves itself. Okay, so there goes the solution, and let's see what is the time complexity of the algorithm. So as you see, we are actually doing it. Basically, we're doing it using a depth first search. So we are actually visiting every node, and every node, after visiting every node, we are actually doing just one operation, right? So if there are like n nodes in the tree, the time complexity is going to be order of n. And the space complexity, since we are doing DFS, the call stack might be, in the worst case, it might be of length n. So I'm going deep, and say all the nodes I'm visiting, I'm not done with any of them. So the call stack may go as deep as the tree's height. So in the worst case, the space complexity is also order of n. Okay, so that's it. Thank you very much. And this is one of the more conceptual problems. The solution is not that much difficult or challenging, but there is a lot of understanding in it. So I suggest everyone just study this problem, and this is one of the very good conceptual problems, and it will help you solve other problems. Thank you very much for watching.